Hi, so this is the final video in the review of the proof of concept software that was produced as part of the Building Trust in the Digital Economy project. And I thought I would cover a couple of things here. Firstly, where could this go next? And secondly, where do its strengths lie? In fact, I'll start with the second one first. So when we started looking at the notarization services out there, that either used a blockchain or some other system, the thing we found was that the cost of registering a single file on such a public notarization system was prohibitively expensive, typically about €5 per file. And for Earth observation, you want to be able to record the existence of petabytes of data stored across tens of millions or hundreds of millions, possibly even of files. So having a cost per file being more than a minuscule fraction of a cent means that the system would not get used. And therefore, we put together a hybrid permissioned open blockchain platform. And it's permissioned in that the administrators are selected and they are the only ones who have the right to add blocks to the blockchain. But anybody can just sign up without any administrator intervention and start sending transactions to the blockchain, i.e. registering files. And then if they show themselves to be good digital citizens, administrators can issue them with more tokens to allow them to register more files. And the tokens also allow for an economy. It allows for a small payment, say me a couple of €100 to register 100,000 or 1,000,000 files, which would nevertheless provide an incentive for parties to participate as administrators in the blockchain. So this is part of introducing a token economy. Then the second thing I said I was going to talk about, although I did mention it first, was where this project could go next. And at the moment, it is just a notarization service. It just allows the public recording of a claim to ownership of a file at a given time by a given identifiable party. And that is, of course, the foundation of being able to prove ownership and provenance. But provenance is something that I find particularly interesting because data products that arrive, they have various inputs. Those various inputs could be in the form of other data or other processed data or raw. They could involve the use of functionality such as AIs in order to process data and produce results. So you have all sorts of inputs that you can have. And then finally, you would have a derived product output, which you would also then register. But what it would be neat to be able to do is to actually show a historical record of what was included and when and who owned those components, because that would then facilitate in tracking the various terms and conditions that would carry over onto the final product. And I think a good parallel here is the concept of supply chain. If you look at the manufacturing, shipment, and ultimate selling of goods, that has a lot of parallels with the digital data economy. In the real world, we see the production of raw materials, which are processed into subcomponents, which are assembled into bigger components to produce a final product. And that product also makes its way through the supply chain pipeline from the initial manufacturer to the final consumer at the end. And there are problems in supply chain in that trying to deduce where things went wrong in the manufacturing and shipping process can be a long and arduous process. And indeed, blockchain is being used there as well in order to solve some of these logistic problems. Now, similar logistic problems exist in the data world, except in that case, it is more about the licensing and terms and conditions that attach themselves to subcomponents or prior data products that are processed to make new products. And I think this is of particular concern in the Earth observation space because some of the data is freely available, for example, the Sentinel and Copernicus data, and some of the data has to be purchased and comes with terms and conditions that apply. So having a provenance chain would be a great next step for this project. And we have some ideas for that already, which are based around the use of the structure introduced by Git, which uses hashes of changes over time in order to build a tree of, or a graph rather, of how a software product develops over time. So applied to the Earth observation data, you would be tracking the hashes of the raw inputs or processed inputs, and then the derived products, and then the subsequently derived products from those using a Git-like structure. And the second thing we were looking at is the Sentinel data format known as SAFE, which is an XML schema that provides a description and a bunch of checksums for Sentinel data. And we see the possibility of adapting that schema in order to also allow for provenance tracking. And then that schema can be written and updated to the blockchain, or rather a hash of that schema can be written to the present system, the proof of concept, at regular intervals, giving you a history of how a particular data product has changed over time, i.e. thereby providing provenance of that. So this was really meant to be a quick wrap up. It's gone on slightly longer than I'd intended, but there you have a summary of what it is we've achieved with the proof of concept and where we think it can go next. I hope you found this all very interesting, and I will wrap it up here. Bye.